All right, so this is just going to be a quick little video to show you how to simplify radicals two ways. So first thing at the top of your notes, it tells you that there's three ways that you know if a radical's in simplest form. The first is going to be the one that you're going to run into the most, where it says there can be no perfect square factors under the radical sign. So I have a list of the perfect square factors on those notes, but these are the numbers that you can take the square root of, and they end up being a nice whole number. So the perfect squares would be 1, because 1 squared is 1, 4, because that's 2 squared, 9, because that's 3 squared, 16, 25, 36, 49, and so on. And the list of perfect squares go on and on and on. So if the number under the radical sign has one of these numbers as a factor, which means if you can divide the number under the radical sign by any one of these numbers, it's not in simplest form. So we are going to learn two ways to simplify radicals. The first, if you had me last year, this is how I would have taught you, and I had a lot of people a fan of it. It's called the cake method. So for the cake method, let's say I want to simplify the square root of 200. So here's how the cake method works. You're going to write your number down kind of near the bottom because you're going to build your cake up. And what you're going to do is you're going to divide out prime numbers, only prime numbers. Now, prime numbers are the numbers that can only be divided by 1 and themselves. So the prime numbers would be 2, 3, 5, 7, 11, 13, and so on. All of the numbers, like I said, that can't be divided by anything except themselves and 1. So if I'm looking for a prime number that I can divide out of 200, I would probably start with 2. Now, when you take 200 divided by 2, you get 100. Now, the next rule in the cake method says don't stop until you get to a 1. That is not a 1. So we're going to add another layer, and now you're looking for a prime number that you can divide out of 100. Well, I'd probably go with a 2 again. So 100 divided by 2 is 50. I'm not to a 1 yet, so I'm going to add another layer, and I'm going to look for a prime number I can divide out of 50. Now I like to just divide out 2's until I can't divide out 2's anymore. So I'd take 50 divided by 2, and I would get 25. Okay, add another layer. What I can divide out of 25 is 5. 25 divided by 5 is 5. Add another layer, and the only thing I can divide out of 5 is 1. Okay, so once you have your cake built, what you've done over here is you have found the prime factorization of 200. If you were to multiply all those together, you would get 200. So what you're going to do is you're going to circle the pairs. So what I see here is I see a pair of 2's and I see a pair of 5's. So the pairs are going to go on the outside of the radical sign. So this pair of 5's becomes 1 5 on the outside of the radical sign. This pair of 2's becomes 1 2 on the outside of the radical sign. Now this 2 that didn't have a pair, that is going to stay on the inside. Now the reason why we do this, sorry, I didn't finish this one out, 5 times 2 would be 10 square roots of 2. Now the reason why this works, if you were to take all of these numbers and multiply them together under the radical sign, 5 times 5 times 2 times 2 times 2, okay, multiply those together, we kind of already established it, you get 200. But if you were to break this apart, 5 times 5 is 25, and the square root of 25, guess what that is? Boom, 5. And then this right here, the pair of 2's, 2 times 2 is 4, and the square root of 4, guess what? 2 right there. That's why the cake method works. So let's do one more of the cake method, and then I'll show you the other, probably quicker method. So let's do the square root of 98x to the 4th. So for the 98, you're going to start your cake down here. We're going to add a layer. Now out of 98, I would probably divide out of 2, and you would get 49. Now the only thing you can divide out of 49 is a 7, and you would get 7. Add another layer, and the only thing I can divide out of 7 is 7. So when I go back, the only pair I have is 7. Now remember what this is the square root of 7 times 7, which is the square root of 49, which is just a 7. Now the 2 would be like the square root of 2, which you can't simplify the square root of 2. So you would just leave it the square root of 2. Now the x to the 4th, what you're going to do with this is you're going to do pretty much the same thing. If you have x to the fourth under the radical sign, every time you can pair up x's, it turns into an x on the outside of the radical sign. So this pair of x's would give me an x on the outside, and this pair of x's would give me an x on the outside, so I'd have a 7x squared square root of 2. Okay, now, the second method is probably that I would say if math comes a little more naturally for you, this is probably what you would prefer because it's definitely quicker. So this one involves looking for those perfect square factors. So, like if I am looking at the square root of 125. Now, I know that that's not in simplest form because I know 125 has a perfect square factor. So remember, the perfect square factors are 1, 4, 9, 16, 25, 49, 64. Probably won't have to go any higher than that, but these are the numbers that you're looking to see. Can I divide any of these numbers into 125? Okay, well, what I see that 25. So what you're going to do is you're going to break apart that 125 into 25 times 5. Okay, now keep in mind when you do this, these numbers are still underneath the radical sign. But now what I can do is I can take the square root of 25 and I get 5. I can't take the square root of 5, so we're just going to leave it as the square root of 5. Okay, and then if I were to try the square root of 48 x to the fifth. Now for this one, once again, we're looking for one of these numbers that maybe I can divide into 48. And you may have to do some checking, but if you check, you would notice that 16 times 3 would give me 48. So you can take the square root of 16 and the square root of 3. The square root of 16 is 4. Can't take the square root of 3, so we're going to leave it as the square root of 3. Now when I take the square root of x to the fifth, remember what you're looking for is you're looking for the pairs of x's. So x times x, there's a pair, x times x, there's a pair. So x times x, I have an x squared on the outside, but notice I've got that one x that's left over. We're going to leave it there on the inside.